Rate of change of quantities, part 2. A stone is dropped into a quiet lake and waves move in circles at a speed of 4 centimeters per second. At the instant when the radius of the circular wave is 10 centimeters, how fast is the enclosed area increasing? Area of circle is given by pi r square. Here, question says waves move in circle at a speed of 4 centimeters per second. It means dr upon dt is given, that is 4 cm per second. We have to find out dA by dt. So dA by dt. If we differentiate pi r square, so here pi into 2r. Since we are differentiating with respect to t, so we have to write dr by dt. Now we put the values pi into 2 into radius, that is given as 10 into dr upon dt is 4. Unit will be cm square per second. So it will be equal to 80 pi centimeter square per second. Now let's consider second question. The total cost Cx in rupees associated with the production of x units of an item is given by Cx equal to 0.005 x cube minus 0.02 x square plus 30x plus 5,000. Find the marginal cost when 3 units are produced, where by marginal cost we mean the instantaneous rate of change of total cost at any level of output. So we are given Cx, which is equal to 0.005 times x cube minus 0.02 x square plus 30x plus 5,000. Now we have to find out marginal cost. Marginal cost means dCx by dx. So it will become 0.005 times 3x square minus 0.02 into 2x plus 30. We have to put x equal to 3 and that will give our answer. Consider next question. The total revenue in rupees received from the sale of x units of a product is given by Rx equal to, Rx is given as 3x square plus 36x plus 5. Now, find the marginal revenue, that is dr by dx. R is function of x. So we differentiated 6x plus 36. Here, x is given as 5, so we can put this value here and we will get answer. Let's see next question. A balloon which always remains spherical on inflation is being inflated by pumping in 900 cubic centimeters per second of gas. Find the rate at which the radius of the balloon increases when the radius is given as 15 centimeters. Here, volume change is given dV by dt equal to 900 centimeter cube per second. Now, formula for volume of sphere is given by 4 by 3 pi r cube. Now we differentiate it with respect to t. So dV upon dt equal to 4 by 3 pi into 3r square times dr by dt. In our question, we have to find out the rate at which the radius of the balloon increases. It means we have to find out dr by dt. So we can put other values like dv upon dt is given as 900 equal to 4, 3 will cancel out, 4 pi times r square, where r is given as 15, so 15 square into dr upon dt, or dr upon dt will be 900 divided by 4 pi into 225. We can evaluate it, and it will unit will be centimeter per second. Question number 5. A balloon which always remains spherical has a variable diameter 3 by 2, 2x plus 1. Find the rate of change of its volume with respect to x. So here, diameter is given as 3 by 2, 2x plus 1. So radius will be 3 by 4, 2x plus 5. Now, volume V equal to 4 by 3 pi r cube. We can put the value of r. So V equal to 4 by 3 pi times 3 cube divided by 4 cube times 2x plus 1 4 cube. Here, a balloon which always remains spherical. So sphere has volume 4 by 3 pi r cube, and it is diameter. So obviously radius will be just half of it, and volume 4 by 3 pi r cube. We have put the value of r cube, so 3 cube divided by 4 cube times 2x plus 1 whole cube. We have to find out dv upon dr, not dv upon dt. Find the rate of change of its volume with respect to x. So that is dv upon dx. So it will become 4 upon 3 pi times 27 divided by 64 times derivative of this. So derivative will be 3 times 2x plus 1 whole square times derivative of 2x plus 1, that will be 2. So on simplification, we can get the answer. Question 6. Sand is pouring from the pipe at the rate of 12 centimeter cube per second. The falling sand forms a cone on the ground in such a way that the height of the cone is always 1/6 of the radius of the base. How fast is the height of the sand cone increasing when the height is 4 centimeters? Okay, here the rate of change of volume is given. So dV upon dt is given as 12 centimeter per. This cone condition is given that height of the cone is always 1/6 of the radius of the base. H equal to R by 6, or if need be, we can use R equal to 6H. And volume of the cone V equal to 1 by 3 pi R square H. Here our question says, how fast is the height of the sand cone increasing? So we have to write volume in terms of height. So we can replace R by 6H. So V equal to 1 by 3 pi 36H square R square times H. So that is V equal to 12 pi H cube. Now we can differentiate it. So dV upon dt equal to 12 pi 3h square dh by dt. Our purpose is to get dh by dt. We can put the values dv by dt. So dv by dt is given as 12. 12 equal to 12 pi into 3 into h square. So h is given 4. So 4 square 16 times dh upon dt, and finally we can get dh upon dt equal to 12 divided by 12 into 3 into 16 pi, and unit will be centimeter per second. This can be simplified. Thank you for watching.